Hi and welcome to Jawad's Academy. Today's lesson is about finding the derivative of any relation using chain rule. Chain rule is another rule that we'll find as an expression for slope of a tangent or instantaneous rate of change. Well, it depends on the given question, always. So we have many different rules to apply finding the derivatives. And again, it depends on the question. So in this case, this is how chain rule works. This is just a general equation that we're going to apply chain rule to this and mix of power rule also. Now, if you remember, the power rule was saying that coefficient times the exponent and subtract 1 from the exponent. But in this case, we're going to apply power rule and chain rule because we have something in expression inside the big bracket to the power of n. So how it works, chain rule. The derivative y prime equals, again, we're going to multiply the coefficient times the exponent, of course, as just like power rule. We leave everything inside the bracket, whatever it is, and then we subtract 1 from the exponent. And then chain rule telling us that the derivative inside of this bracket multiplies by the outside. So it'd be f at prime of x. Whatever f of x is, the derivative of that multiplies by the outside of this whole bracket, big bracket. So this is chain rule. I hope the explanation is clear, but in order to understand, of course, the rules a lot better, we're going to apply to an example. And the example would be something like this. Y equals 2, bracket open, x squared minus 1x plus 4 to the power of 5. Now, here we can apply power rule and chain rule. So it means like, in other words, in simple language, if you look at it, we're finding the derivative from outside to inside. From the power to inside the bracket. So we're going to apply power rule first because we're going to multiply the coefficient of the bracket by the exponent of this bracket, and then we subtract 1 from the exponent of the bracket. Right? So let's apply. So 2 times 5 is 10. We're going to leave everything, whatever it is, inside the bracket, whatever it is, and then we subtract 1 from the exponent, which is 4. 5 minus 1. And then chain rule says the derivative of inside of that bracket multiplies by the outside. So we bring the derivative of this outside multiplies by the whole thing here. So the derivative inside, we're going to again multiply power rule. Derivative of x squared as 2x. Derivative of negative 1x will be negative 1. The constant is equal to 0. So now this is an expression for slope of a tangent using chain rule. Let's do another example, and this second example will make it more clear how to use chain rule. I'm hoping by now it's already clear, but again, it won't hurt us to do more example. Example number 2 would be y equals square root of x squared plus 2x plus 5, for example. Okay, in order to apply chain rule to find the derivative of this expression, let's rearrange, writing it as exponential exponent form. So getting rid of the radical, we write the radical in exponent form. So it would be x squared plus 2x plus 5 to the half. So rearranging it from radical to that form. We can do that because so we can apply chain rule. So now we go from outside to inside. If we were to use simple language, right? Which makes math a lot easier if we are using simple language. So we take the derivative of outside, which is the coefficient multiplies by the exponent of the bracket, would be half. We leave everything as is inside the bracket. Then we subtract 1 from the exponent, which would be negative half. Then, whatever the derivative of inside of this bracket is, we bring it outside the bracket, multiplies by the whole thing. Remember that. That's how chain rule works. So the derivative of x squared would be 2x plus the derivative of 2x is just 2, and constant is equal to 0, so we're not going to go ahead and write that. This is the derivative of this expression right here, example 2. So if you were to have a value for x to substitute into this derivative expression, you will find the slope of a tangent to the curve at given value for x. We can also simplify this, put it in simplest form, in order to, if we were to match the answer in the back of the book. How would you do that? And now we have a negative exponent. To make it positive, you bring it down. So what do we have on top? We have only 2x plus 2. The 2 is in the bottom with the square root of x squared plus 2x plus 5, because we have to the power of negative half. When you bring it down, it becomes positive half, which means radical. So we rewrite it back as the square root of x squared plus 2x plus 5, and the coefficient is 2 because this 2 comes down also, multiplies by this. That's another example of chain rule. We push it up a little bit so you can see. There you go, that's the answer. In simplest form. Not really, we can also take a common factor of 2 here. If you wish to put it in very simplest form, we can have a common factor of 2. You can see there. So we take the 2 out, we left with x plus 1. Why not? We can reduce with this 2 here, and what we have, this 2 is gone, and then at the end what we have is x plus 1 over square root of x squared plus 2x plus 5. Now that is in simplest form. There you go. Now you can see it. Perfect. So I'm going to stop right here. Please don't forget to subscribe, thumbs up, and if you have any question, please leave in the bottom and comment box. And at the same time, don't forget to subscribe. Much appreciated. Take care. See you next time.